What we did yesterday, we had done conditional probability, and we have seen the probability of occurrence of event A such that B has already occurred. So हमने यहाँ condition लगा दी है कि A तब होगा जब B हो चुका होगा. So we have seen that this probability is probability of A intersection B over probability of B. Then again we have seen that two events will be independent if. So please, I'm not saying if and only if probability of A intersection B is same as probability of A into probability of B. Right? So, okay. So if you see, there is one more thing which I want to discuss in this topic now, that is mutually exclusive events. तो अगर आपको याद हो जब हमने definition की थी तो mutually exclusive events का मतलब क्या था? Disjoint events. So disjoint events का मतलब क्या था? They cannot occur simultaneously. So A intersection B is equal to 5. So these are disjoint events. So from here, what will be probability of A intersection B? Probability of A intersection B will be 0. Right? So, so from this, let us discuss one thing. So suppose A and B are mutually exclusive events. Right? So mutually exclusive events with positive probabilities. So probability of A is greater than 0, probability of B is greater than 0. So this is this. From this, I mean, suppose let us say we are rolling a dice and we are saying A is an event that we get an even number, and B is an event. So A is an event, we get even number. So even number क्या हो गया? 2, 4, 6. And B is an event which is an odd number. So 1, 3, 5. So what is probability of A? Probability of A will be favorable cases. So favorable cases 3 है, total cases होते हैं 6. So 1/2. Probability of B कितना हो जाएगा? कितने cases मेरे favor में है? 1, 3, 5. 3 cases. Total कितने होते हैं? 1, 2, 3, 4, 5, 6. So again 1/2. So if you see, both these events have positive probability. And what is A intersection B? So you see A intersection B is empty. So there is no number which is both even and both odd. So probability of A intersection B is what? 0. Right? So this is the case. So A and B are mutually exclusive events with positive probabilities. Right? अब हमें पता है from this definition. Right? From this definition. Right? So यही definition हमने की थी probability of B mod A के लिए. So what is probability of B mod A? It is probability of A intersection B over probability of A जो नीचे है. So अगर मैं A को उधर भेज दूं तो probability of A intersection B क्या बन जाएगी? Probability of A into probability of B mod A, and this is same as probability of B into probability of A mod B. तो अब अगर आप देखो हमने क्या लिया है? हमने mutually exclusive events लिए हैं. तो mutually exclusive events का मतलब क्या हो गया? Probability of A intersection B is 0. So probability of A intersection B is 0, right? But again probability, so you see product of these two numbers is 0. Similarly product of these two numbers is 0. But हमें पता है probability of A भी 0 नहीं है, probability of B भी 0 नहीं है, because they are positive. So only possibility is what? Probability of B mod A is equal to probability of A mod B. So that is equal to 0. So probability of B mod A is equal to probability of A mod B, so that both are equal to 0. So इसका मतलब क्या हुआ? So now you see probability of B mod A is equal to 0, but हमने ऊपर क्या लिया था? Probability of B was positive, so probability of B is not equal to 0. इसका यहाँ से अगर मैं compare करूँ तो यहाँ से क्या आ गया? Probability of B mod A is not equal to probability of B. Similarly, what we can show is probability of A mod B is not equal to probability of A. It means both the events are not independent, they are dependent, because हमने यही तो definition करी थी कि हमारा जो events हैं independent events का मतलब क्या होता है? Probability of B mod A should be equal to probability of B. Similarly, probability of A mod B should be equal to probability of A, right? So it means these events are dependent. So what I mean to say is कि mutually exclusive events, right? हम कई बार सोचते हैं कि intersection empty है, means they cannot occur simultaneously, so they are not dependent on each other, they are independent. No, mutually exclusive events does not means independent events. Independent events कौन से होते हैं? अगर probability of A intersection B is equal to probability of A into probability of B, right? So you see, this is what I am writing. So mutually exclusive events are always dependent, right? So if A and B are independent events, right, with probability of A and probability of B positive. So if A and B are independent, right, and probability of A, probability of B is positive. So what do you get? What is probability of A intersection B? A probability of A intersection B हमें पता है क्या होती है? Probability of A into probability of B. So probability of A and probability of B are both positive. So इसका मतलब ये product कभी भी zero नहीं होगा. So you see this event can this product cannot be zero. So it means probability of A intersection B cannot be zero. So it means if A intersection B की probability zero नहीं हो सकती, so means A and B cannot be mutually disjoint sets. So ऐसा नहीं है कि mutually disjoint होगा तो independent होंगे. No, this is not the case. Right. So before I move further to an important theorem, so these are small results for the conditional probability. So this we have already seen. So now if you see probability of A mod B, हमने definition से देखा था probability of A mod B क्या होता है? Probability of A intersection B over probability of B. And we know probability is always greater than equal to 0. So numerator is always greater than equal to 0. Denominator is always greater than equal to 0. So this total probability is always greater than equal to 0. Right? Actually जो हमने 3 axioms करी थी, जब हमने एक्सियम प्रोबेबिलिटी शुरू करी थी, एक एक्सियम थी एक्सियम ऑफ नॉन नेगेटिविटी. सो उसमें हमने किया था प्रोबेबिलिटी ऑफ एनी इवेंट ए इज ऑलवेज ग्रेटर देन इक्वल टू 0. एक हमने की थी प्रोबेबिलिटी ऑफ सैंपल स्पेस इज ऑलवेज 1. एक हमने की थी अगर सेट्स की इंटरसेक्शन एम्प्टी है तो सम ऑफ प्रोबेबिलिटी ऑफ देयर यूनियन विल बी नथिंग बट द सम ऑफ द प्रोबेबिलिटी. वही 3 एक्सियम्स हम यहाँ भी देख रहे हैं. तो द फर्स्ट एक्सियम वाज द एक्सियम ऑफ द नॉन नेगेटिविटी. नाउ सेकंड इज प्रोबेबिलिटी ऑफ एस मॉड बी. So again sample space आ गया तो probability should be 1. So S mod B. Just let us apply the definition. So what is probability of S mod B? So this is probability of S intersection B over probability of B. Again, this is my sample space and this is B. So what will be S intersection B? So S intersection B is nothing but B. So probability of S intersection B over probability of B. So you see this is probability of B, this is probability of B. So probability of B over probability of B. So this is equal to 1. Right? Again, next thing. If A1, A2, so on up to AN is a sequence of disjoint sets. So again, these are the sequence of disjoint sets. So what I want is probability of union AN. So this is union over AN mod B. Again, let us apply the definition. So this is what? This will be union over N. So हमें पता definition क्या बोलती है? AN intersection B. So probability of A intersection B over probability of B. Right? तो अगर मैं इसको open करूं, so this will be what? This will be, if I just open this, so this will be A1. So this will be A1 intersection B, A2 intersection B, A3 intersection B, right? So whole union can be taken outside. So this is this union N, AN intersection B over probability of B. So again, what is given to me? It is given to me that A1, A2, AN are disjoint sets. So if you see, so this is something of this sort. This is my A1, this is my A2, this is my AN. So they are disjoint sets. That doesn't have anything in common. So obviously अगर मैं इन सबकी intersection भी किसी common set के साथ लूंगी, say I take intersection with B, तो that again has to be disjoint. Because अगर इस intersection में कुछ हुआ, if any X, so if any, so say suppose any X, any element X belongs to AN intersection B. तो इसका मतलब क्या हो जाएगा? X will belong to AN. I mean, just yes. So what my claim is that this intersection is empty, right? So AN intersection B is empty for all N. So you see, अगर कोई X इसमें belong करेगा AN intersection B में, तो what will happen? X will belongs to AN for all N. So obviously X will belong to their intersection also. But हमें तो given है that they are disjoint. I mean all these sets are pairwise disjoint, right? So इसका मतलब क्या हुआ? This intersection cannot have anything in common. So if you see, this is what? Probability of union AN intersection B, where all these sets are again disjoint. Where all these sets are again disjoint. तो हमें पता है अगर intersection disjoint हो, तो यूनियन को हम आई मीन इफ द सेट इज डिसजॉइंट देयर यूनियन इज डिसजॉइंट, तो हम उसको ब्रेक कर सकते हैं. सो यू सी दिस यूनियन बिकम समेशन, सो समेशन ओवर n प्रोबेबिलिटी ऑफ ए एन इंटरसेक्शन बी ओवर प्रोबेबिलिटी ऑफ बी. अगेन इस पे अगर मैं फॉर्मूला लगा दूं तो क्या बन गया, दिस इज समेशन ओवर n प्रोबेबिलिटी ऑफ ए एन मॉड बी. Right, so what we want to say from here is कि जो ये conditional है, ये this is just a symbol. Otherwise, whatever properties you have done for basic probability, they all remain same here. Whatever comes, so just apply the definition and we will get the result. So these are all again some small results. So जैसे कि हमने पहले किया था, now this is complement. So probability of A bar mod B. Again, let us apply the definition. So this is what probability of A bar intersection B over probability of B. अब ये अगर आपको याद हो, हमने formula किया था, right? So what is this formula? So this formula is probability of B जिससे बार नहीं है minus probability of A intersection B. नीचे क्या है probability of B? Again, let us divide this. So probability of B over probability of B is 1. So 1 minus probability of A intersection B over probability of B. So you see this is what probability of A intersection B over probability of B. So this is probability of A mod B. So 1 minus probability of A mod B. So यहाँ से क्या आ गया? So probability of A bar by B is equal to 1 minus probability of A mod B. Right? So similarly, next theorem if you see, so probability of A union B mod C will be what? Same formulas. Probability of A mod C plus probability of B mod C minus probability of A intersection B mod C. See, सिर्फ नीचे mod आता जाएगा, जो भी नंबर नीचे mod में है. So proof wise it is again easy. Just apply the definition. So what? Let us take what is left hand side. Left hand side is probability of A union B mod C. Right? So what will be this? So this will be probability of A union B. So the probability of set intersection C, right, over probability of C. Again we know this is distributive property, इसको हम break कर सकते हैं. तो ये क्या बन गया? Probability of A intersection C union, right, union. यहाँ पे please ये ऐसे नहीं आएगा, so please you can rectify. This will be probability of A unions A intersection C union A B intersection C. Yes, over probability of C. So this is say probability of A intersection C यूनियन बी इंटरसेक्शन सी. प्रोबेबिलिटी बाहर है, दोनों के साथ अलग अलग नहीं है. सो नाउ इफ यू सी दिस इज प्रोबेबिलिटी ऑफ वन सेट union another set. So one set is A intersection C, another set is B intersection C. तो हमने अब यहाँ पे हमें ये नहीं दिया हुआ that this union is disjoint. It can have something common. तो हमें फॉर्मूला पता है. Probability of A union B क्या होता है? Probability of A plus probability of B minus probability of A intersection B. So same फॉर्मूला हम यहाँ लगा देंगे. So what we get? So you see, first set is A intersection C. So probability of A intersection C plus probability of B intersection C minus probability of, अब अंदर क्या आ जाएगा? अंदर आ जाएगा probability of first set intersection second set. So again if you see इस set में C दो बार आ रहा है, but we know any set intersection with itself is nothing but it's the set itself. So this can be written as what? Probability of A intersection B intersection C. So that's it. So we just apply this formula here. So what we get? Probability of A intersection C plus probability of B intersection C minus probability of A intersection B intersection C. और नीचे denominator में probability of C था, वो common आ रहा है. So if I just apply the definition now, तो first fraction क्या बन गई? First fraction is probability of A mod C. Second fraction is probability of B mod C, and third fraction is nothing but अगर आप A intersection B को एक set मान लो, so this is A intersection B mod C, right? So all the formulas are coming from the main result only. So let us go to the next theorem. So what does next theorem says? Probability of A intersection B complement mod C plus probability of A intersection B mod C is same as probability of A mod C. तो basically B का रोल खत्म हो जाएगा because B और B का complement दोनों आ रहा है. तो we will just apply the definition. So what is left hand side? So what is left hand side? So what is left hand side? So अगर मैं definition लगाऊं, so left hand side will be probability of A intersection B bar intersection C over probability of C plus probability of A intersection C intersection B over probability of C. Right. So now if you see here what is happening. So अगर आप देखो A intersection C. So suppose this is A, this is my B, and this is my C. So if you see, हम क्या कर रहे हैं? A intersection C. So this portion is A intersection C. This portion, this yellow portion is A intersection C. तो अगर आप देखो A intersection C का कुछ, so this portion of A intersection C is in B, and this portion of A intersection C, let me draw just one white line in between so that we are able to see. So white portion का जो इधर वाला portion है वो B में है, और जो white portion के इधर वाला yellow portion है वो B बार में है. तो अगर आप देखो, अगर आप A intersection C intersection B बार ले लो and A intersection B intersection B बार ले लो, right? So you see this is nothing but both the sets are disjoint sets. एक का पोर्शन B में है, एक का पोर्शन B बार में है, तो ऑब्वियसली प्रोबेबिलिटी का सम हो रहा है. सो यू सी दिस कैन बी रिटन एज व्हाट? दिस कैन बी रिटन एज प्रोबेबिलिटी ऑफ A intersection C, right? A intersection C intersection, I should not write it this way, so we can write directly. So directly only if you see, आप add कर रहे हो कौन सी probabilities को, A intersection C का वो portion जो B में आ रहा है और जो B बार में आ रहा है. So you see, if आप इस पूरे portion को add कर दोगे, तो you will again get back this set only, this complete set only, this whole set. So you see, this probability is nothing but, by definition, this is by set theory. So this is the reason sets always helps. So this is nothing but A intersection C back. So this is probability of C. So this is nothing but probability of A mod C. Right? So अगर आप A intersection C का एक portion B में है और एक portion B बार में है, दोनों को obviously एक combine कर दोगे, तो you will get back your again the complete set. Right? So again the theorems continue. Right? So what this next article says, for any three sets A, B, and C, and sample space S, such that B is subset of C, so B is a part of C, and probability of A is greater than 0. So what we have to show is probability of B mod A is always less than or equal to probability of C mod A. So we will just apply the definition again here. So what is probability of C mod A? So probability of C mod A is nothing but probability of C intersection A over probability of A. तो अभी जैसे हमने पीछे लिखा, so C intersection A को हम क्या लिख सकते हैं? C intersection A को हम लिख सकते हैं C intersection A intersection B union इसी सेट की intersection with B complement. So C intersection A intersection B complement, दोनों की union. And again, since this union is disjoint, so we can write this as probability of B intersection C intersection A plus probability of B bar intersection C intersection A. Obviously नीचे दोनों में क्या चल रहा है? Probability of A चल रहा है. So again, so now if by definition, what is this? What is this? So B intersection C intersection A over probability of A. So this is nothing but probability of B intersection C mod A. And similarly, what is this? This is probability of B bar intersection C mod A. तो यहाँ से क्या आ गया? Probability of C mod A, right? Probability of C mod A. Again, if you see, B is subset of C. So B is subset of C. This is given to me. So obviously B intersection C will be B. B intersection C will be B. So you see probability of B intersection C. B intersection C क्या बन गया? This is B. So probability of B mod A plus probability of B bar intersection C mod A. So if you see probability of C mod A कैसे मिल रहा है? प्रोबेबिलिटी ऑफ बी मॉड ए में कुछ ऐड करके, सो ये जो कुछ है दैट इज ग्रेटर देन और इक्वल टू 0. सो फ्रॉम हियर व्हाट वी गेट, प्रोबेबिलिटी ऑफ सी मॉड ए इज ऑलवेज ग्रेटर देन और इक्वल टू प्रोबेबिलिटी ऑफ बी मॉड ए. सो आई डू वन मोर आर्टिकल here. So Bayes theorem, let's see. Okay. So these questions are important. So if A and B are independent events, so A and B are independent events. So जैसे ही independent events आए आपके दिमाग में एक चीज आनी चाहिए, probability of A intersection B is same as probability of A into probability of B. So this should come in your mind, right? So A and B are independent events. Then what you have to show, first part is A and B bar. A and B bar are also independent. A and B bar are also independent, right? So just let us apply the definition. Now since A and B are independent, therefore probability of A intersection B is equal to probability of A into B. So हमें क्या show करना है, A and B bar are also independent. So we have to show probability of A intersection B bar. So this is same as probability of A into probability of B bar. Right, so let us apply. So what is probability of A intersection B bar? By definition, this is probability of A minus probability of A intersection B. But A and B are independent, so probability of A intersection B कितना हो जाएगा? Probability of A into probability of B. So probability of A is common. So what is this? 1 minus probability of B. So 1 minus probability of B is nothing but probability of B complement. So you see, probability of A intersection B bar is equal to probability of A into probability of B bar. तो यही तो हमें प्रूफ करना था. So यहाँ से क्या आ गया? A and B are independent. Similarly, on these lines, again same proof. Say we can show that probability of A bar intersection B will be same as probability of A bar into probability of B bar B. तो वहां से क्या आ जाएगा? A bar and B are also independent events. So next is A bar and B bar are also independent. So A bar and B bar are also independent. So again, let us consider probability of A bar intersection B bar. So probability of A bar intersection B bar, right? अब यहाँ पे हमें एक स्टेप यूनियन वाला हमें पता है, अगर आपको याद हो, आप कॉम्प्लेक्स में भी करते थे, डी मॉर्गन्स लॉ होता है, सेट थ्योरी में सेम लॉ होल्ड करता है. सो प्रोबेबिलिटी ऑफ ए बार इंटरसेक्शन बी बार, दिस इज सेम एज प्रोबेबिलिटी ऑफ ए यूनियन बी बार. मतलब बेसिकली अगर यूनियन पे पूरे पे बार है तो वो इंडिविजुअल में बार आ जाएगी और यूनियन जो है इंटरसेक्शन में चेंज हो जाएगी. सिमिलरली अगर आपके पास है प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी होल में बार, सो दिस इज सेम एज प्रोबेबिलिटी ऑफ ए बार, दोनों में बार आ जाएगी और ये जो इंटरसेक्शन है ये यूनियन में चेंज हो जाएगी. दिस इज नोन एज डी मॉर्गन्स लॉ. दिस इज नोन एज डी मॉर्गन्स लॉ. ये सेट थ्योरी में ही लॉ होल्ड करते हैं, कॉम्प्लेक्स में भी ये लॉ आपने देखे होंगे. सो वी आर यूजिंग दिस प्रॉपर्टी ओनली. सो यू सी प्रोबेबिलिटी ऑफ ए बार इंटरसेक्शन बी बार, ये कितना हो जाएगा? सो दिस विल बी प्रोबेबिलिटी ऑफ ए यूनियन बी होल बार. सो अगेन दिस कैन बी रिटन एज व्हाट? 1 माइनस प्रोबेबिलिटी ऑफ ए यूनियन बी. So that's it. So 1 minus, what is the formula for probability of A union B? This is probability of A plus probability of B minus probability of A intersection B. Let us open the bracket. So 1 minus probability of A minus probability of B plus probability of A intersection B. So again 1 minus probability of A minus probability of B. So A and B are independent. तो ये क्या बन गया? Probability of A into probability of B. So what is happening? Let us take probability of A common from these two brackets. Right, so moment you take probability, so what we are left with 1 minus probability of B. So probability of A common ले लिया, माइनस प्रोबेबिलिटी ऑफ ए कॉमन ले लेते हैं तो क्या बन जाएगा? पहली टर्म 1 बन जाएगी, दूसरे में सिर्फ प्रोबेबिलिटी ऑफ बी बच जाएगा. सो इफ यू सी 1 माइनस प्रोबेबिलिटी ऑफ बी, 1 माइनस प्रोबेबिलिटी ऑफ बी. सो अगेन 1 माइनस प्रोबेबिलिटी ऑफ बी इज कॉमन. सो दिस इज हाउ मच? 1 माइनस प्रोबेबिलिटी ऑफ ए. So 1 minus probability of B is nothing but probability of A B complement, and 1 minus probability of A is nothing but probability of A complement. तो यही हमें प्रूव करना था. So probability of A complement intersection B complement is same as probability of A complement into probability of B complement. So therefore the two events are independent events. So before I stop, although मैंने ये क्वेश्चन, so ऐसे इसके बेसिस पे क्वेश्चंस आ जाते हैं, right? So this is one of the questions from your book. So if an MBA job, in an MBA job in two firms X and Y, so there are two firms X and Y, a person applies. The probability of his being selected in X, तो एक दो फर्म्स है X और Y, दोनों में एक पर्सन अप्लाई करता है, तो उसकी जो प्रोबेबिलिटी है कि वो x में सिलेक्ट हो जाए दैट इज 0.7. सी ऑलवेज प्रोबेबिलिटी में अगर क्वेश्चन फटाफट स्ट्राइक करना है, बेस्ट थिंग इज डिफाइन द इवेंट्स साइड बाय साइड. सो हियर द फर्स्ट इवेंट इज लेट द पर्सन गेट सिलेक्टेड इन the firm X. So obviously let this name this event as A. So A is the event that the person gets selected in X. So what is the probability of A? This is 0.7. And it's being rejected in Y. So rejected in Y का मतलब क्या हो गया? 0.5. Right? So again B is the event. Let the person get selected in Y. तो हमें क्या गिवन है? रिजेक्शन की प्रोबेबिलिटी गिवन है. सो प्रोबेबिलिटी ऑफ बी बार कितनी हो गई? 0.5. तो यहां से प्रोबेबिलिटी ऑफ ए बार निकल गई 0.3 बिकॉज टोटल सम इज 1. अगेन प्रोबेबिलिटी ऑफ बी बार गिवन है तो प्रोबेबिलिटी ऑफ बी भी कितनी आ गई? 0.5. नाउ the probability of at least one of his application, beta at least one of his application being rejected. So rejected का मतलब क्या हुआ कि वो दोनों में ही select नहीं हुआ. Rejected means he is not selected. So what he is saying, at least one. तो जब भी at least आता है, at least means union. Either, so हम कहते हैं ना either A or B. Union means either A or B. Similarly, at least means either A bar. So या तो वो A bar X में reject हो जाए, so that is A bar, या वो Y में reject हो जाए, so that is B bar. So this he is giving as 0.6. So what is the probability that he will be selected in one of the firms? So you see what he wants कि वो किसी एक firm में select हो जाए. So obviously either वो A में select हो जाए और वो B में select हो जाए. So what he want? So he will be selected in one of the firm. दोनों में भी select हो जाए तो भी कोई problem नहीं है. He should be selected. अगर क्वेश्चन ये होता कि एग्जैक्टली वन ऑफ द फर्म में वो सिलेक्ट हो, ही शुड बी सिलेक्टेड इन एग्जैक्टली वन ऑफ द फर्म, तो हम यूनियन नहीं लेते. बस यहाँ पे क्या है कि he should be selected in the one of the firms, right? So if that is the reason we have calculated probability of A union B. So we know what is probability of A union B. अभी हमने De Morgan's law, so we know this is what 1 minus probability of A union B complement. So again De Morgan's law से क्या हो गया? 1 minus probability of A complement intersection B complement. तो अब ये प्रोबेबिलिटी हमें निकालनी है किसकी? A complement intersection B complement की, right? So इसके लिए if you see now, so now we need the probability of A union B. So right, there are very many ways. So one way I am doing here. So what is given to you? You are given probability of A bar union B bar. So if you see probability of A bar union B bar, अगर मैं union का फॉर्मूला लगा दूं तो क्या हो जाएगा? Probability of A bar plus probability of B bar minus probability of A intersection B bar. So यहाँ से probability of A bar intersection B bar निकल गई. So probability of A bar union B bar, probability of A bar भी पता है आपको, probability of B bar पता है. So this you get. So from here we can calculate probability of A union B. So there are lot many ways by which you can calculate what you call it as